Hi class, today we're looking at Chapter 7, Lesson 4, Subtracting Linear Expressions. What we will learn is how to subtract linear expressions and how to solve real-world problems by subtracting those linear expressions. Our vocabulary: a linear expression is an algebraic expression in which the variable is raised to the first power. Now, one thing to remember is when subtracting linear expressions, you are subtracting like terms. As with adding linear expressions, you can use models and zero pairs if needed. For our first example, we have method 1, using the model. So we can use a model by subtracting. So in this case, I have 5x plus 4. So I know that the longer rectangular tiles represents my variable, and there are 5 of them. And then I have 4 of my constant tiles. And since they are all positive, I know that when I subtract them, I'm going to find my zero pairs. So in this case, I have 3 more of the rectangles. And because I'm subtracting, I'm actually going to take away my zero pairs. So I will take 1 from here, and that would take 1 from there. Take 1 from here, 1 from here, 1 from here, and 1 from here. And that leaves only 2 of the longer rectangulars, which are just the x value. And then the constants, I know I have 2 on this side, so that means I would take 2 away, 1 from each, and that leaves me with just 2 of those. And they are positive. So now in this case, my final answer ends up being 2x plus 2. Now, another way of doing this is by simplifying. And so when we simplify, we notice that the negative actually can be distributed to the 3x and the 2. So then I end up keeping the first parentheses the same, so 5x plus 4. But then the negative is distributed to the 3, so I get negative 3x. The negative is distributed to the 2, so I get negative 2. Now I can combine my like terms, 5x minus 3x, positive 4 minus 2. And I evaluate 5x minus 3x, which is 2x, and then 4 minus 2 is positive 2. So in the end, I still end up with the same solution, whether I use a model or simplifying method. Now in the second example, again, we can use a model. So in this case, I have 3 of my variables, and then I have 2 of these constants. But now in this next one, I have minus a negative 2. So in this case, I do have a negative 2 of my tiles as the coefficients, and then I have 1 of the positives. Now, because it says that I'm subtracting, I know that if I'm subtracting a negative number, it's actually adding on. So these end up becoming positive. So they actually change to a positive value. Therefore, I'm adding them to the rest of my coefficient tiles. So I actually have a total of 5 of these tiles, and they are all the coefficients. But for the constants, I noticed that I started with 2 on this side, but now I only have 1. But this 1 is being subtracted. So I take 1 away from here, 1 away from here, and it leaves me a 0 pair, which means I'm left with just one of those constant tiles. So then my answer is simply 5x plus 1. Now another way of doing this is simplifying method. So again, I can use distributive property by distributing the negative to the second parentheses. And I have 3x plus 2. And then I'm going to have a positive 2x minus 1. And I rearrange to put my like terms together. And I end up with 3x plus 2x, which is 5x. And then 2 minus 1, which is positive 1. And so my final answer is 5x plus 1. Go ahead and turn your notes over to the back side now. Now, for these examples, we can use the simplifying method or we can use a model if we want to. But in this case, I am going to show you the simplifying method where we distribute. So I'm going to distribute the negative to the second parentheses. And I'm left with 7x minus 12 and negative 4x plus 3. Then I'm going to combine my like terms, 7x minus 4x minus 12 plus 3. So 7 minus 4, I get 3x, negative 12 plus 3, and I end up with negative 9. And 3x minus 9 is my final answer. Then in part B, I'm going to distribute again the negative times negative 3, and then negative times 2x. So now I have 8x minus 4 and positive 3 minus 2x. So now 8x minus 2x minus 4 plus 3. 8x minus 2x is 6x minus 4 plus 3 is negative 1. So 6x minus 1 is my answer. Now in part C, I'm doing the same thing. I'm going to distribute the negative to the negative 2x and to the 1. So now I have negative 3x minus 5. That stays the same. And this time it's going to be positive 2x minus 1. I combine my like terms, negative 3x plus 2x, then minus 5 minus 1. Negative 3x plus 2x is negative 1x, and negative 5 minus 1 is negative 6. Another way of writing this could also be negative x minus 6. So both would be considered correct. And lastly, in part D, I'm going to distribute the negative to the x and then to the negative 2. So now I'm left with x minus 7, then negative x plus 2. And I rearrange x minus x, then negative 7 plus 2. Now x minus x is actually 0, so they cancel each other out. And negative 7 plus 2 would get you negative 5. So 0 minus 5 is simply negative 5. And that is my final answer. Now in this section, you can solve real-world problems by subtracting linear expressions. In example 2, the expression 8x plus 48.75 represents the total amount of money the soccer team earned from selling X t-shirts. In part A, if the team had to pay 2x plus $24 in expenses, write an expression to represent their profit. So now in this case, we know that 8x plus $48.75 is going to represent the total amount. So we take that total and we create the first parentheses. Then we find the difference with the second, so 2x plus 24. So now in this case, I'm going to distribute the negative, and I'm going to keep 8x plus 48.75, and I have negative 2x minus 24. I can combine my like terms, so 8x minus 2x, then plus 48.75 minus 24. And I simplify my answer to 8x minus 2x, which is 6x. And then 48.75, I'm going to subtract 24, and I end up with plus 24.75. And that is my new expression, my simplified expression, finding the difference between the expenses and the total, so I can find the profit of how much they'll make. So in part B, if the soccer team sold 54 t-shirts, what is their profit? I would take this expression, 6x plus 24.75, and I substitute in 54 for x, and 6 times 54, I end up with 324. I add that to the 24.75, and their total profit ends up being $348.75, and that would be the answer of their profit. Now go ahead and take a few minutes to practice these 4 problems on your own. You may use simplifying method or you may use the models. Either way, just make sure you pay very close attention to your integer rules.